Good afternoon again, everyone. I'd like to welcome you to today's webinar focused on the implementation of low carbon plans. So with many municipalities now having low carbon plans in hand, they're focused on getting the projects implemented and delivering the savings. So in this webinar, you'll hear from technical experts who will explore some high impact greenhouse gas reduction measures and take a closer look at the real world challenges that municipalities are experiencing when moving from planning to implementation. So we'll highlight some approaches for overcoming the barriers and share some lessons learned along the way. Just some housekeeping items. Please reserve the chat for any technology or questions unrelated to content, and make sure that the panelists and hosts are receiving those messages. If you have any questions related to the actual content, please use the Q&A option. That way, all the questions and answers get documented, and we can share that after the event. Any question we can't get to during the webinar, we will have a Q&A session at the end, and anything that can't be answered will be covered in a Q&A document and circulated after the event. Next slide. So just a little bit about the Mayor's Megawatt Challenge for those of you who don't know us. We really are a member-driven program, so really focusing on what our members want to hear about. So focusing the content and the projects, the webinars on topics of interest to our members. We're also a very data-driven program, so we, using monthly utility data, can provide individual customized targets for individual buildings and showing the savings potential in the buildings and where that can be achieved. Again, that's all using monthly utility data. And we're also really focused on sharing of knowledge and best practices between the members, either in webinars or member networking sessions. And you can visit our website to learn more about us. Next slide. So just to remind everybody, the climate challenge is not going away. The municipalities are really leading by example with the climate challenge. So set very aggressive targets, ranging from 50% greenhouse gas reductions by 2050 to net zero emissions by 2030. So the Mayor's Megawatt Challenge really came together focusing on how to achieve these commitments. But now the focus is really going on showing progress towards these targets. So are we making progress towards the targets? I'm really focused on showing results at this point. So next slide. So Enerlife, who provides the technical direction for the Mayor's Megawatt Challenge program, have completed over 75 low carbon studies for a wide range of municipal building types and a wide range of provinces and different municipalities as well. We've really learned a lot of lessons along the way from these studies, and that's what we'll be sharing with you today. Next slide. So here's some guiding principles for the development of these low carbon studies. So really, it's really important to be clear on what your municipality wants to achieve. Do you have specific targets in mind? Does your municipality need to reach net zero by 2050 or sooner? Or are there other objectives as well? So is there equipment coming to end of life that needs immediate replacement? Or are there other maybe operational challenges in the building that you want to overcome? Getting organized early, again, super important, getting all of the data that you have and knowing what you have. So do you have monthly data? Do you have interval data? Do you have trends from the BAS? So really knowing what you have and starting to collect that and knowing how you can access that. So next, so involving facility staff and operators early. Can't stress this enough. Facility staff, they know the building best. They know the nuances in the building. They know of any operational challenges that could make implementing the measures challenging. So really getting their input early is really key, and their buy-in as well, really key. Another principle, so integrated design really does get better results. So bringing everyone to the table, really looking at the project as a whole system instead of separate parts. Really everyone working together to make the optimal choices and really achieve the emissions that everyone's looking for. Also, business cases, we all know how important making the business case is. So really focusing on that incremental difference is really important. So really stressing with business as usual measures, they're going to need to happen anyway. So you're going to be spending that money anyway. So really focusing on that incremental difference between going as with business as usual or like for like and the low carbon scenario. So really the difference between those is key. And life cycle costing, making sure everyone understands life cycle costing is important. So everyone in the municipality, from the facilities level right up to finance, life cycle costing is super important, provides a holistic view, really incorporates all costs associated with an asset. So bringing in operating expenses, maintenance, repairs, disposal, really bringing in all of those factors, which allows for really more informed decision making, allows for really objective comparison between alternatives, such as choosing like a high efficiency HVAC system, because it reduces operating costs in the long term, for example. Some more guiding principles really in terms of the plan itself. So we always preach energy efficiency first, get your building operating as well as it can, bringing those loads down as low as they can before implementing any capital measures. So always efficiency first. So time your project implementation, starting with immediate returns, like operational measures that are typically low cost and have good net present value and paybacks, and time those early, and then the end of life replacements to follow. So knowing when those end of life replacements are happening. Implementing a building automation system early. That's also very important to be able to implement some of these operational measures like nighttime setbacks, ice temperature optimization, measures that are really going to give you a lot of savings for not a lot of investment. So really getting that system in early. We do have some webinars on our website that you can check out about building automation systems. Maximizing heat recovery, again, really important. There's a lot of waste heat is rejected, particularly in arenas from the refrigeration plant. So really utilizing as much of that waste heat as possible to use it in other areas of the building. Again, really important. Aligning measure implementation with asset management plan. So again, bringing in your asset management plan so you can really align those measures. So when you know equipment is coming to end of life, you have alternative solutions and also time to prepare for those. So if a boiler needs to be replaced in 2028, for example, you would have options and have time now to plan for those. So really getting that alignment is key. Bundling. So this is again really important for the business case. So bundling those more simple measures that are high return with measures that maybe don't have as great a return to make the whole package more viable. And make sure also to include timing and costs of education and training, not just for operations staff, but for the whole municipality. These are often costs that can get overlooked when it's coming to implementation. So really making sure that's accounted for, the training pieces in particular. And then when making design choices, we really must consider ease of operations and maintenance. Again, this is why it's so important to bring in facility staff early to get their feedback on any operational challenges and what their input would be into the design. Again, really important. And system interactions, electrical infrastructure limits. We'll get into more details with this when my colleagues get into some of the detailed measures that we'll be looking at. So this is the process for the feasibility study or low carbon plan. I'm really relating this back to what I was originally talking about with the guiding principles. So make sure that you have clear objectives, clear targets. What are you looking to achieve? Are there specific reductions you're looking for? Are there particular replacements that you're looking to implement in particular years, for example? Collecting data and other information. I mentioned this before, but really knowing what you have, how you can get it is really important. I'll get into the data in a little bit more detail shortly. In-person site visits and interviews are really important. Again, interviewing facility staff because they really do know the nuances of the building and can provide really critical information when developing and then implementing the plan. Reviewing measures and priorities with the whole team. So again, that integrated approach, bringing everyone together so they're not operating in silos. And that would also be in the integrated design workshop, again, bringing all staff together, energy management staff, facility staff, to technically review the measures and any possible implementation challenges. And that would be followed by a financial workshop where you bring in capital, your finance staff, and asset management staff to really look at the timelines, the initial costs, the net present values of the measures. And then a final report. And really, the most critical piece that we learned along the way is an implementation workshop. So a plan is really just a plan until you implement that plan. And then there's a lot of factors that need to be considered in that. For example, your asset management, procurement. How are you going to get projects procured? For example, how are you going to make the business case? And really those details. So really to take the plan to the next stage. And just a little bit more on the objectives and targets. I've missed this or I've mentioned this a few times now. So really know why you're doing this. Has your municipality declared a climate emergency, for example, that you need to respond to? Is there critical equipment at end of life that you really need to find a replacement for, a low carbon replacement? So again, what are you trying to achieve? Are there targets? Are there other objectives? Maybe there's high humidity levels in the building, different operational concerns that you want to get addressed. And figuring out where you need to get support and how are you going to get that support. So really engaging council, other staff, operators, all the way through the process, and really start focusing on how to get it done. So which buildings, how are you going to do it? Will it be one building at a time? One particular measure, for example, lighting across all facilities. So really thinking about that rollout plan as well. And next slide. So a little bit more on the data because it is really, really important. Knowing what you have, monthly data. Do you have interval data, hourly interval data, for example? If not, how can you go about getting that data? Do you have any sub-metering data that you have access to? Do you have energy management software where you can access that data easily and share that easily? Critical documents. These are really important, not only for the study, but really when it comes to implementing plans. So making sure you have all drawings available, mechanical, refrigeration, electrical, architectural, structural. These drawings are really important when moving to the implementation stage, particularly just as an example, solar PV, having the structural drawings are super important for that. Of course, you can always get drawings later, but whatever you have available will keep costs down when it comes to going through with the implementation. So really collecting those drawings, digitizing them if possible, and really gathering all of that information. And that would also include any sequences of operations. So how does equipment operate and when? BAS trend logs. Do you have BAS? What equipment is it controlling? And can you access those trend logs? Can they be accessed remotely or do they need to be done on site, for example? And then any other audits that have been done, building condition assessments. All of this is really great information when you're moving to the implementation stage. It just makes everything a lot easier when you have all of this in place. And the integrated process. So working together, we really do feel I stressed this a number of times that everyone working together instead of in silos really does lead to the best solutions. So really bringing together the resources, the processes from the different teams, all coming together to really drive home that the good performance in the end, which is what everyone's looking to achieve. And without further ado, I will turn it over to Sean Mitchinson. He's an energy analyst from Enerlife. He was involved in most of the low carbon plans that we were working on, and he's going to share some insights that we've learned along the way.
Thank you for that, Catherine. So As Catherine mentioned, my name is Sean Mitchinson. I'm an energy analyst here at Enerlife, working on these low carbon studies. I'm going to talk about some of the common energy conservation measures that we've come across as part of these studies, and then I'll pass it off to my colleague Kajan Singham, who will discuss the implementation side of things. Before I get to the energy conservation measures, or ECMs as I'll refer to them, um, I just want to give an overview here, sort of recap a lot of what Catherine discussed in regards to the overall process or pathway for these pathway to low carbon buildings from the feasibility study onwards through the implementation of the various measures. So to get started, we'll start at the left side here with the base emissions. So this is the low carbon design brief. So this is the site visit, the data collection, understanding the history of the building and how it operates. So the operator interviews are very important. If there's any BAS data, you can collect data through that. But the operator interviews understand operationally, what are the hours of operation, building type, how is the building being used, also collecting all of the equipment data. So that's nameplate photos, review all of the drawings, understand how the building is operated and what equipment is being used. From there, it depends on the nature of your brief, whether it's an ASHRAE level 2, 3 audit, a calibrated energy model. You want some way to qualify and quantify all of that data to get a relatively accurate understanding of how energy is being consumed in the building. And from there, you can determine with a relative accuracy how the impacts of different energy conservation measures and how much energy would actually be saved from various upgrades. Perhaps you have a furnace that you imagine or you think it's going to be consuming a lot of energy, but when you dig into it, you realize maybe there's different units or baseboards serving that space as well that take the priority sequence. It's an internal space not getting much infiltration, a variety of considerations, but actually doing that analysis will give you a better understanding of what kind of savings you can expect. Going from energy, once you understand how energy is consumed, you can translate that into emissions. So of course, different electricity grids have a different net amount of greenhouse gas or GHG emissions per unit of energy generated. Ontario is a relatively clean electricity grid. We work across Canada. Provinces such as Saskatchewan are much more highly emitting relative to Ontario. So when you understand the utility breakdown of the building, you can correlate that to what your baseline emissions are. And once you have that quantified, you can look to see how can we reduce ideally emissions, but also energy consumption, utility costs. And as Catherine mentioned, the main metric we use for financial analysis is the net present value, which is essentially the cost of ownership of the asset. And I'll discuss that in just a few moments when I discuss the asset management system. So once you have your baseline emissions, the first step is, like Catherine mentioned, efficiency first. So we want to ensure the building is operating that low-hanging fruit. Not before you get into the major capital investments, you want to make sure the building's operating as efficiently as possible. And the reason for that is you don't want to spend extra money on a 10-ton unit when an 8-ton unit would do. And then once you put those efficiency measures in place, your 10-ton unit's operating at a poor location on its part load performance curve. So you want to make sure you have the building operating as efficiently as it can be, whether that's through outdoor air scheduling, various measures that we'll discuss in the coming slides. Once you have that in place, you would look at the more capital measures. So that's upgrading your fuel-fired RTUs to either high efficiency or ideally some form of electric air source heat pump unit to really target the greenhouse gas emissions reductions. So we've made sure the building's operating as efficiently as we can in terms of operations, and then we've upgraded and replaced equipment at its end of life with higher efficiency options. Once that's complete, we want to move on to heat recovery. So it's not applicable to every building. We work with a lot of hockey arenas, but hockey arenas, grocery stores, anything with a large scale cooling, you are dumping or dissipating a lot of heat right out into the environment just to get rid of it. And meanwhile, you're burning natural gas in the adjacent space to heat the lobby. So that's obviously not ideal. And that's a big thing we want to look at is recovering that heat to reduce the amount of fossil fuel being burned or even electricity, the amount of extra energy being used to heat the space. But outside of hockey arenas or grocery stores, data centers, there's also just typical exhaust ventilation heat recovery. So heat recovery ventilators, energy recovery ventilators, just capture any and all of that waste heat to improve the overall building efficiency. Wastewater as well. There's a lot of heat in wastewater. So whether it's a water treatment plant, anything with a large amount of gray water, um, tapping into sewage lines, that's a bit beyond the scope of one single building, but something to be considered there. There's a lot of waste heat available, and you can see you can further reduce the amount of energy that the building requires by taking advantage of heat that is otherwise wasted to the environment. Once that's complete, your building will still have some energy consumption, no matter how efficient you make it. So once we've made the building as efficient as possible and incorporated heat recovery, the next thing we want to do to achieve low carbon is offset any remaining consumption with a renewable energy resource. So in our study, we primarily look at solar photovoltaic or solar PV panels, but there's also, you could do geothermal, biogas, biomass, energy storage, just some way to offset the remaining energy consumption of your building and thus the remaining carbon emissions of your building. It might not make sense in every situation to completely offset all of the greenhouse gas emissions with, say, a solar panel, whether that's just restrictions from the net metering agreement, the financial benefits of doing so. So if you're trying to achieve full net zero, then for any remaining emissions, your next step would be to purchase renewable energy credits or RECs or carbon offsets just to fully make the building net zero. Looking at the bottom of the screen here to tie back to what Catherine had discussed before. So we start with the low carbon design brief. And the most important thing is we want to align our low carbon planning with our existing asset management. We use net present value again, which is the cost of ownership of the asset. It's a great metric that allows you to compare all costs associated with operating an asset over your study period. And it's very helpful for comparing units that have different life expectancies. So it's more favorable for these asset management systems than, say, just a simple payback or a return on investment. It allows you to fully compare the cost of ownership of different options over a study period. And you're not, so in our studies, we look at the incremental difference between what we call business as usual and low carbon. To operate a building, it's going to cost money regardless. These aren't Wall Street investment funds where you're going to turn a huge profit all of the time. Sometimes just heating a lobby isn't going to turn you a profit. But what we can see is, okay, an air source heat pump costs a bit more upfront, but over the 30 years, with reduced utility costs, carbon tax is a conversation. But with all of these various potential savings, which option ends up having the lowest cost of ownership throughout the 30-year or whatever your study period is? Cost of ownership, obviously, we always recommend proper equipment maintenance and repairs. If you're replacing your domestic hot water heater every 5 years, it's going to cost you more over 30 years than if you're able to replace it every 15 years. So another example for that is we don't recommend replacing a furnace that you put in 2 years ago. It still has a lot of life expectancy left. Let's stage our low carbon options to implement the new measure when the existing unit is being replaced anyway. And let me just find the button to skip slides here. Perfect. So this is a non-exhaustive list of typical low carbon measures that we've seen looking at the municipal portfolio of buildings. Again, it's non-exhaustive, but we can see some common measures. So eliminating fossil fuels, moving to electric resistant space heating. To be more efficient than that, we can go with the heat pump technology for space heating. We mentioned heat recovery, so that's heat or energy recovery ventilators on the air side. The water side tab, this is referring to a hydronic loop. So collecting or reclaiming the heat from the condenser, the cooling tower that's otherwise being dissipated out into the environment, and instead injecting that into a hydronic loop, which could be connected to your various rooftop units, air handling units, hydronic unit heaters. So just recovering that heat for space heating purposes. It's important to note that you can't always guarantee, nor will you always have sufficient heat from your ice plant, for example, available exactly when you need it. Your ice plant is going to be operating less in December as opposed to September. It's just colder outside. You need less from your ice plant. And conversely, you need more heat during December, January, of course. So it's always important to note that you'll need a backup fuel source, a boiler for the hydronic loop, could be electric, fossil fuel, depending on your goals. We have envelope upgrades, so increases to insulation levels in the roof, walls, triple pane windows, energy efficient doors, trying to mitigate the effects of thermal bridging. Definitely a bigger consideration for new builds. Existing buildings, it's a bit tougher to handle that. Improving air tightness, reducing the amount of uncontrolled infiltration into the space. Low emissivity ceilings or reflective roof coatings primarily applied to spaces where you're trying to keep the cooling load down. So ice rinks, for those who don't know, the reflective roof coating, it's a light colored exterior coating to the roof to reduce the amount of heat that the roof absorbs. The roof of an ice rink, it's in the sun all day. It collects a lot of heat, and the ice surface below is much colder, but freezing temperatures. So there's a lot of heat radiating from that ceiling to the ice. It's a big part of the heating load on the ice plant. So we want to mitigate that either with a reflective roof coating or a low emissivity ceiling, which just acts as a barrier for that radiation. Renewable energy, so solar photovoltaic panels, geothermal, etc. Some low-hanging fruit, LED lighting and occupancy sensors, low flow and flush fixtures. Building automation system, Catherine touched on, and I believe Cajun will touch on later as well. That's essentially putting a brain in the building, and I would consider it a cornerstone of low carbon buildings and energy efficient operation. So that's adding a building operation system. It gives you access to potentially, depending on the system you put in, trending, fault detection, data management, just insights into the building that you wouldn't otherwise have, and hopefully more sophisticated controls. So if you don't have it already, outdoor air scheduling, demand control, ventilation, temperature setbacks, lighting sensors, and perhaps outdoor air reset temperatures for your boiler loops. Variable frequency drives, not sure why that's indented, but so variable frequency drives, whether for your ventilation fans, your pumps for boiler loops, brine pumps for arenas, just modulating the flow of your system to the actual requirements needed at that time. Again, we have on the water heating side, we have electric resistance, going with more efficient. We have heat pumps, instantaneous water heating, eliminating essentially the tub of hot water that's constantly losing heat to the surroundings. Hopefully it's insulated to minimize that, but there's an opportunity for savings by eliminating those standby losses. Low GWP or global warming potential refrigerant equipment replacements. So whether that's RTUs, air conditioning units, they all have a refrigerant in them, and they do have some amount of embodied carbon designated by the global warming potential. So ice plants, we work with a lot of facilities across Canada that are still using R22, and R22 has been phased out in Canada due to its high global warming potential. The costs of R22 have gone up exponentially. The access to it has gone down. So tying that back into your asset management, how can we ensure that when we make an investment in our ice plant, we are investing in not only a refrigerant that is good for the environment, but also won't break the bank? Whether that's an ammonia plant or a CO2 plant, something with a natural refrigerant with a zero global warming potential should be safe from any future refrigerant phase outs. Cold water ice resurfacing for arenas. So the reason floodwater is heated is to degas the floodwater before it's added to the ice to make for a stronger connection to the ice. Cold water ice resurfacing, instead of using temperature to do so, you use pressure. So you're using less fuel to heat the floodwater. You're adding less heat to the ice surface. If you have it, there's obviously less hot water being added, so less moisture in the space, less evapotranspiration. So if you have a dehumidifier, you're reducing the load on that. If you don't have a dehumidifier, you're reducing the moisture issues in the space. Last one, just various electrification of process and plug loads, whether that's an ice resurfacer, kitchen equipment, forklifts, whatever your building might have, just eliminating any fossil fuels there. I think I'm doing okay for time. So what we're seeing here is a table, energy savings potential. And the most important thing that I could say about this slide is that we are trying to group a lot of high-level information into a relatively digestible table with just a high, medium, and low bucket. When Cajun just starts speaking in a moment, one of his favorite expressions is the best answer in engineering is it depends. All of these measures we've grouped based off what we've seen, but it depends. It depends on the baseline usage patterns, the electricity grid. For one building, Let's see an example. For one building, low flow flush fixtures. Perhaps if it's just a typical office building where you're just having a few hand sinks, you're not going to get a huge amount of savings there overall to the building. But if for a pool or an arena where you're having a lot of showers with high use, high flow, um, and then between the water you save and the less fuel needed to heat less water, it could be bumped into the medium. So it depends. We tried to organize it relative to the intrusiveness of the measure, the relative performance of the measure. So on the high side, we have water side heat recovery and air side heat recovery. So like we saw in that chart before, reducing the amount of heat being lost in the environment while we're burning fossil fuels next door, that's going to have a high energy savings potential. The control measures, so outdoor air scheduling, demand control, ventilation, temperature reset schedules, great opportunity for energy savings there. The reason we're bringing in outdoor air is for the occupants and indoor air quality. But if your RTUs, AHUs are currently operating 24/7, not only are those fans running 24/7, but you're bringing in a lot of cold outdoor air that needs to be heated to the space temperature. If you're able to schedule that outdoor air around occupancy, there's a great opportunity for energy savings. Variable frequency drives as well, low emissivity ceilings, as I've mentioned, the radiative load from the ceiling to the ice rink contributes a large amount to the heating demand. So finding ways to reduce that. Cold water ice resurfacing, solar panels. I wouldn't say energy savings because you're still using the energy. You're just offsetting it with solar, but there's a high opportunity there. Heat pump space and water heating relative to pure electric. You're eliminating by going from fossil fuels to electric, you're getting some inherent savings from increased burner efficiencies, but that's primarily an emissions reduction measure. Heat pump technology is just more efficient than the resistance. On the low side, increasing insulation levels. That's another example I could give on. It depends. For buildings that have dedicated ventilation, it's always good to increase your insulation levels so you have better climatic control of the building. But if you're having outdoor air brought in, that's going to be the primary contributor to your heating load. The rest of these lighting occupancy sensors, there's been advancements in LED technology. Prices have come down. Those are always typically have an attractive cost of ownership relative to the like-for-like replacement. I won't discuss all of those. If there's any questions, we can address them. Looking at now the same table, but on the emissions side. So it's the same measures grouped, just reorganized based off their emission savings potential. And again, as Cajun would say, it depends. And this time, not only do we have to worry about the baseline usage patterns, also the electricity grid comes into play. Every electricity grid, as I mentioned previously, has a different amount of emissions generated per unit of energy. Currently in Saskatchewan, their electricity grid is more emitting than natural gas. Long-term decarbonization planning always centers around the elimination of fossil fuels. But if we were making this table for 2024 Saskatchewan, it would be reorganized differently. Ontario is a relatively clean electricity grid, so we have organized it here. And what you'll see is any measures that primarily target electricity savings are on the low side. It's always great to reduce the amount of energy consumed, but looking at it, the electricity from the Ontario grid is relatively clean. So those are grouped in the low side here. Medium, we have electric resistant space heating with heat pump space heating on the high side. So we're eliminating the fossil fuels, and heat pumps are just a more efficient method of generating that heat. Again, heat recovery, air side and water side. We're reducing the amount of typically fossil fuels, but energy being used for heating, while this heat is just being dissipated right outside through the condenser. Outdoor air scheduling, all of the control measures, efficiency first, as Catherine said. It's can often be the low-hanging fruit, and just reducing your demand will save you annually, but also when you look at your equipment replacements. Cold water ice resurfacing, again, reductions to floodwater, typically fossil fuel, but notable reduction on ice plant load, dehumidification, etc. And low GWP refrigerants, depends on the refrigerant that's being phased out, but it's just important to acknowledge the embodied carbon of these refrigerants. And last one is the operating cost savings potential, which again, this is based off the Ontario electricity grid. Typically throughout Canada, electricity is more expensive than natural gas. So we're seeing sort of an inverse of the last slide. So the measures that save primarily electricity are moved to the high side. That's the solar panels, variable frequency drives, low emissivity ceilings, reducing the load on the ice plant. Again, we have heat recovery on the high side. One thing I will note is that water side heat recovery, it can be a costly measure, especially for implementing it in existing buildings. So this is not a holistic picture, which is why we look at the net present value of the assets. So we're looking at annual utility cost savings, but capital costs are something that come into effect as well. But regardless, heat recovery is going to save you annually, again, with the controls, making sure the building's operating as efficiently as it can. And then on the low side, we have the electrification measures. So anything that's adding new electricity that was previously fossil fuels, it depends on the profile, but in general, you're moving from a cheaper fuel source to a more expensive, so that's on the low side for operating cost savings. Again, we've worked with some buildings in smaller communities where they don't have natural gas piped directly to their house, and they're relying on local deliveries of propane, fuel oil. So the relative cost of those fossil fuels can make for electrification to be more financially attractive. But I think with that, that's an overview of the energy conservation measures, and I'll pass it off to Cajun to discuss the implementation.
All right. Thanks, Sean. So, this is we're getting to the implementation section of our presentation. You can go to the next slide. This is just, some of the things that we've learned throughout our process, different projects or some research and discussions that we've had with a lot of different teams. And I guess to start off with, we'll just break it down to some components, like what the implementation process entails for the most part. Starting off with the first part, making the case for action. There's three major elements that we find, the business case, the material case, how do you quantify how much better is it to do this, take this low carbon approach compared to your business as usual case. Your business as usual will be, replacing things the way they are, maintaining the operations, the systems. And oftentimes, we're not really sure how much better it is or how much worse it is. Sometimes we think that it's because it's low carbon, it's more expensive. It doesn't always pay back. But looking at the incremental difference, often you'll find that there is a good number of low carbon situations that will be more positive. The next one is going to be the environmental case, future proofing, building resilience, making sure that this facility is able to handle the changes in the climate, the changes in the environment, the shifts in weather patterns and seasons, or just building a more resilient building, not just for climate, but also people. So people have shelters and things that they need in terms of natural disasters or cases where they need shelter, shelter like I mentioned earlier. So there's business, the material case, the environment case, and within the business environment case is also, of course, reducing emissions, reducing energy, a lot of this stuff where we quantify these potential savings. And the last one is going to be the community leadership. And when I say community leadership, it doesn't just mean the council and the people that are leading the charge at the building level or the operations, but also the actual residents. You want to get buy-in from your residents, make sure that they understand why this is a critical developments and why these renovations are needed. How does this benefit their future planning? How does it benefit their future goals and the future of the community itself? And this leads into the senior leadership support for the implementation plan. Without having support in any way, you're not going to be able to get anything done. The support comes through, like we mentioned, council, having champions, municipal champions, as Catherine has mentioned earlier on, an integrated process, having people that have bought in and see the value in doing these projects, see the value implementing these different low carbon approaches, and meeting your objectives. People that are all aligned and having that support is going to be critical in getting things to move forward. And obviously, we all understand that financing is going to be one of the biggest barriers that we have, is how they get funded. Making sure that you're, finding incentive programs, working with provincial or federal programs or service providers, trying to align with your capital plan, your asset management, making sure that you're actually, like Sean had mentioned earlier, replacing things as they're needed, understanding how things are going to be coming up for replacement in the future, setting these things into phases and stages, seeing how you can accomplish all these tasks in digestible digestible way. So you're not doing it all at once or overwhelming any one system or portion of your organizations or your municipalities, and able to accomplish these goals over the time period that you're aiming for. And resourcing is the next challenge, which is who's the one leading it internally. That's why we do mention that the need for having a municipal champion or organizational champion, sustainability champions that do push these initiatives forward, find ways to build these cases, build these cases for action, whether it's the environment, the business, or the community. And being able to, seek out these funding sources, understanding the landscape, the policy landscape, seeing all these things and coordinating all these things. You need someone to help lead the project in the right direction. And resourcing when it comes to skills and knowledge, that's one of the other challenges. You're not going to have, not everybody has like an in-house expert on, infiltration or air testing and balancing. You're going to need to find and work with different teams. That's what it comes down to, building the right team that you need based on the project goals, based on your objectives, based on what you're setting out to achieve. And we'll talk about that in a bit. And knowledge and skills is one of those harder things to grasp and kind of really know what do you need, and what you need, you only find out as you go through the process, which we can talk about right in the next slide when we go to what we've identified as a project development process. You can probably just go to the end to number 10. So I guess I'll just talk about at the Climate Challenge Network, we've worked on a few research projects, a lot of different implementation projects or discussions with design engineers, architects, owners, operators, contractors. And through a lot of these discussions, what we've come to develop is this diagram over here, which we call the process development or project development process. And we have made it a single, straight line. It seems like a straightforward pathway, but we understand for the most part, not everything is in a straight line. It is more of a web at the end of the day. There's going to be crisscrossing between things. Sometimes they go from 4 to 7, 6 to 5, or 6 to 4, and there'll be a lot of dotted lines and a lot of scenarios where things are going to be based on the situation. And like Sean mentioned, things depend. Things are going to be changing depending on what the climate is, how things change, whether it's at the organizational level, the government level, or just at the community level. So starting off with the pre-planning and the policy landscape, one of the most important things is understanding, like, where are you starting from? What is your long-term capital planning? Do you have this planning and set up, understanding what's going to be replaced? How long you intend to keep this facility or whatever your operations going? And understanding the demographics, understanding the policy landscapes. These are going to be, pretty critical just to kind of set the foundation of what you're working off of. Going into project inception and planning, like Catherine had mentioned earlier on, the objectives really matter. You need something to help ground you in understanding what do you want to achieve, what are your targets, what are your goals, and what can you work within. And knowing that scope can help make you understand how you would go through this whole process, and always have somewhere to kind of center yourself when you're unsure about any changes that are going to be happening, because there will be a lot of changes, a lot of hiccups or things that you're not expecting. How do you kind of bring yourself back to what you intended to achieve? And having an idea of the incentive program applications gives you an idea of, okay, now where's your boundaries that you can set on what you want to do and how much you can actually, how far you can go. So once you've gone through the planning stages, there's a budgeting and feasibility, finding out what is actually possible, what makes the most sense, how can you reduce your emissions as best as possible, how do you actually achieve the goals that you're setting out, the objectives you made, what kind of energy targets you have and everything. We believe life cycle costing analysis is one of the best ways, especially when it comes to large projects, looking at the incremental differences, especially looking at the business as usual case. There's a lot of times the business as usual case seems like, keeping things the same is probably the cheapest, sounds intuitive, But when you look at low carbon cases and you look at the emission savings and the energy savings and the cost savings, whether it's even water savings, all these things start stacking up, reduce maintenance, um, improved operations, optimizations. All these things can stack up and can make low carbon cases a lot more appealing when you do these analysis. And that's why you go through this feasibility stage, you find out what your ideal pathway is, and then you go into the design and engineering phase. So through this phase is, a lot of the complications start coming up where you start recognizing your barriers. You have the integrated design team to kind of help you discuss this. You want to build this team that can all communicate and collaborate and make sure everybody's in the loop, making sure that they know that, okay, this is not going to work out that well. We need to make space for this. There's going to be some issues with this given the limitations of the building on, whatever aspect that exists. And you kind of reiterate. There's a lot of iterations that goes through this stage. And that's when, obviously you'd want to minimize the iterations, but you do want to do as best of a job as you can here. But at the end of the day, like I mentioned, it's a web. So things will always come back. Things will always, change orders are going to be required at some point. And you want to make sure that, okay, does this change our final goal at this point? Do we have to readjust? How can we kind of not value engineer away everything? The idea is you want to be able to be within your boundaries. Like I said, you always want to stay grounded with your objectives and find out how can you achieve the best with what you have, with the limitations and the barriers that you'll be running into. And the design and engineering phase, ideally, that's where you kind of tackle and figure out those limitations as soon as possible before you start getting into, the procurement and tendering phase and the construction phase. And I think everybody has seen that, the exponential graph where the later you do something, the more changes you have to do something, the more expensive it gets. So ideally, a lot of this stuff gets sorted out as early as possible at these stages. Procurement and tendering, having good delivery models, making sure there's accountability baked into all this, making sure that people are having maybe performance guarantees or whatever systems or elements you want to be putting in place to ensure that you're actually getting what you're asking for, ensure that your objectives are being met at the end of the day. A lot of this stuff is going to be, a case-by-case basis, depending on the organization, depending on the needs and how the operations work. So these are a few stages where you want to get, learn from other people, learn from people's mistakes, people's successes, and that's when, why we have these sort of sessions to kind of share these ideas. When you get to the construction phase, collaboration is going to be one of the most important things between the trades, whether it's HVAC envelope controls. You want to make sure that no one is left out of the loop. People are not, left to the end where everything is already done and you can't make any changes. Again, this goes back to the integrated design, making sure that everybody's working together, everybody's working towards the same objectives, and everybody's grounded to what those objectives are. Going on to tab and commissioning, we think that performance-based commissioning is going to be pretty critical, as it, is one of those things where we see tab and commissioning pushed to the very end, pushed to a very small corner because, timelines and delays and things come up. There's a lot of inertia that kind of slows things down. And then you start thinking, you don't have that much time. You don't want to spend too much time on some of these things, but we do think it's critical to get these stages right, because it's going to carry you over to a much longer timeline than the construction itself is the building's operations. The building life cycle or the system and equipment life cycle is going to outlast how long it took you to build it, or how long the construction took, how long the procurement took. And those could have a much longer lasting impact if you don't do the commissioning and tab stages, as comprehensive as as is ideal. And having optimized BAS controls, performance verifications, like we said earlier, having accountability, performance guarantees, whatever systems you can have in place that can ensure that these systems are not just planned, the ideas are not there, but it's also operating as expected. It's also doing the thing that you wanted it to achieve, which is whether it's saving energy, reducing emissions, making operations easier, improving health and wellness, whatever that might be. And when we go into handover and training, we've got the building operator engagement and training. One of the most important things we think which is making sure that the people that are operating the facilities understand why these systems are connected to the way they are. Why are they set the way they are? What is the intention? What is the logic? What are the fundamentals behind them? So when they want to make changes, they understand the best way to make changes. And having this documentation, having a clear AES interface, and a clear plan or multiple plans for different situations is going to be critical to making sure that the building is operating as best as it possibly can. Going into the occupancy and operation, communication with the staff and the occupants. And these are the people that are going to be using the building the most. You want to make sure that they understand how things are changing, that they, are happy about the changes, that they can make the most out of the changes, and that they can use the facilities, whether it's controls, whether it's, low flow fixtures, whatever it might be, understanding that, if you have a low flow fixture, don't keep the water running 3 times as long just because it feels like it's not as high as the pressure. Little things like this, turn the lights off. You want to make sure that you're monitoring and trending things and making sure that you're keeping an eye on how things are operating and people are engaged in the operations of the building itself. And life cycle operations, continuous MMV, recommissioning, making sure things are constantly improving, preventative maintenance, looking at new ideas, new technologies are always coming out, finding ways to renew infrastructure, make smaller upgrades, make small optimizations as you find opportunities along the way. And the dotted line is that this is all going to be a feedback loop. You got to learn your lessons from your experiences, from other people's experiences. These will build new policies, new legislations. These will build new incentive programs as people find the needs, whether they need to invest in more LEDs or they found that, oh, most people have already done LEDs, so now we need to invest money somewhere else. So, there's going to be a cycle of this repeating itself over and over again. And we're going to be finding out, this is just, like I mentioned, a straight line, but there's a lot of webbing and crisscrossing between all these sections. This is just what we've learned through our experiences and our discussions with a lot of different teams across Canada. So going into the next slide, we will be talking about, what are some common potential barriers? And this is just kind of like a breakdown of some high-level barriers that we find people will frequently run into. Of course, financial, like I mentioned, capital upfront costs is always going to be the big one, especially when it comes to really big renovations. And we do recommend looking at net present value or NPV as a metric that can help looking at the incremental difference. How much better is it going this approach versus what you would have already done? And then it's going to be personnel capacity, internal staff, making sure that you have people that can operate things, understand how they're operating, make changes, adapt to changes as they need to. External staff, having SMEs, subject matter experts, experienced contractors that understand what is needed, how the new technologies are working, how these connections are operating, how the BAS systems need to be configured. All these things, making sure that you have internal and external staff, that could be a challenge depending on the type of systems, because not all systems that are coming out have many experienced installers available, or have people that have done these types of projects all that frequently. So, finding the people that are able to help you achieve the outcome, that's going to be one of those barriers that you might run into, depending on the type of measure you're trying to implement. Impacts on programming, you want to make sure that your facility still stays open. You want to keep that revenue stream coming in. You want to make sure that, the community has access to whatever they might need to over the time periods. So finding out like what is going to cause any downtime, these are things that you'll be looking into. It's a potential barrier that you'll be having, whether you have to close down your ice rink, trying to do it during the off season if you can, if you want to make any rink specific changes. Infrastructure, of course, structural, electrical, these are common ones, whether there's space problems or vibration problems, or you need to add ducting and piping and you're not sure about the spacing available. A lot of this stuff gets tackled during the engineering and design phase. Electrical capacities, understanding what is available at that location. If you're trying to do net metering with photovoltaics, is there bi-directional metering available, grid connections, all these things, considerations to have. And additional barriers to implementation, of course, council leadership, the people part of things, understanding like, are people on board? Do people understand the value of it? Do people see how they can benefit from it? Not just council and leadership, but the clients or residents, whatever they might be, whatever the stakeholders, whoever the stakeholders are, the operators of the facility too. You want to make sure everybody's on board to being able to achieve a common goal. If we go to the next slide. So, again, like Sean mentioned, we are trying to break down some complex things into very simple tables, and everything will depend on the project, the location, what the starting conditions are for whatever facility might be. This is our rough idea for a lot of different measures that we've done to give people an idea of what can they explore, what have they explored, and what they might experience as a barrier. So when we look at those same measures that Sean had described just a bit earlier, we look at some of the measures that have low to no barriers. LED sensors, LED lighting and sensors, you're really swapping out bulbs, or you're adding in sensors that might have Wi-Fi. You don't have to do too much wiring if you need to. Variable frequency drives, these don't really have, they're not that expensive. They don't really impact programming all too much. They're going to be, they're not going to be having too many structural electrical issues. Low flow fixtures, same ideas. Improving air tightness. When we think of that, we think of like sealing window and door transitions, adding caulking to the corners of walls and things. So for the most part, we're not looking at a full envelope redevelopment or anything. Cold water ice resurfacing, one of those measures, and outdoor air scheduling control measures that requires personnel, requires people to actually implement it. How does this affect, do they understand how it works? Do they understand how to adapt to changes? Whether it's, the cold water, if it's freezing differently, if the ice temperature is different and the cold waters are reacting differently than what they're used to. Can they understand how to adjust for this? Can they understand how to make the changes that are needed to achieve the same or better ice quality? There's training for a lot of these things. And same for the BAS controls, there's training for a lot of these things, making sure that people understand how to use the tools that are available to them and not just, kind of offload that into something else and then not take too much attention and care, which can lead to, situations where you have a long running stream of whether you've forgot to set the outdoor air schedule and you're having 24/7 outdoor air coming into the facility because you weren't sure of how the controls were quite set up. And you want to make sure this training and onboarding is critical. And when we look at different types of measures, like reflective roof coatings, instantaneous hot water heatings, they're going to have different types of barriers, whether it's structural or electrical. Air side heat recovery, it's one of those things that can impact programming because you might be have some downtime on your ventilation systems, structural, your ducting, your space vibration. If you're going to be adding new ventilation systems like ERVs or HRVs, same idea with low emissivity ceilings, space structure. Is there spaces to hang these, to suspend these ceilings? Are you going to be doing it during the off season? Do you have a year-round ice season? Looking at process equipment, so like there's a lot of different measures that start building up barriers, and obviously financial is one of them. Sometimes it's not just the cost of the equipment, but the expense of the energy, because electricity can be a lot more expensive. Going to electrification can, have different challenges because you'll have an increase, operational expenses, even if your capital expenses might not be so much. And going low carbon, some of them, have high capital expenses, but reduce operational expenses. You have to find a way to balance this stuff. And that's what we mentioned, looking at things like net present value, makes all of these together to be able to find the ideal options. So I won't go through all of these. I will mention a couple of them, like I guess going back one slide, like things like water side heat recovery. It's one of those situations where it could be more expensive or less expensive depending on what are you working with. Do you already have a boiler system? Do you already have much of piping in place? Or are you like mostly using air side systems, using furnaces and RTUs? How do you you know, change this into a water side system to be able to capture a lot of the heat recovery from ice plants? There's going to be different situations. It's going to be really dependent on the type of building and where you're starting off from. Um, but that is giving a rough idea of the types of barriers that you might experience. And like Sean mentions, I say a lot, it really depends. So additional considerations, testing and balancing for major equipment. Uh, this is going to be just critical, like I mentioned earlier, on the phases to make sure that you are operating the best way you can, so you can have a lifetime of great operation, not just an idea of how it should operate on paper somewhere, and then not actually doing that for the next 20 years of operation. Right sizing equipment, so you're not having systems that are operating at part load a bunch of times and just not using the full capacity, losing a lot of efficiency through these things. And it's going to be really important for future proofing and building resilience in facilities, especially with the changes in climate. Sensor calibrations, making sure that your DCV controllers or DCV sensors are reading the right ppm, so they're not over or under ventilating. Measurement verification and trending. One of the most important things that we've mentioned is BAS, being able to know where you are, being able to be held accountable to those energy savings that you're seeking out, or the operations, being able to optimize these things over time, doing those continuous measurement and verification and commissioning, recommissioning efforts. Going to be these are two things that are going to be really critical: having the history of your facility and an idea on how to project how the future can be improved, or for the facility at least. And the next slide. And last but not least, the success factors, really having a municipal champion again, making sure you have someone that leads the charge and sees these connections. It is a web of things when it comes to implementation and successfully implementing projects. It is a lot of connections between different people, different teams, different professions, and different needs, different stakeholders, all kinds of things. And you want to have someone that is at the center of this, that understands this, hears people's needs and requests, and finds a way to make the most out of it. You're not going to have a 100% perfect system, but a municipal champion is going to be able to help center and keep everything grounded. And council support is one of the most important things, like we mentioned, making sure that your community understands the needs and the values in future proofing, in resilience building, in the business case. As like you mentioned, oftentimes it can be very positive when you go low carbon, and in giving a better future to whatever the residents are seeking out, whether it's better resilience, new programming, or new opportunities. External funding, grants, these are obviously going to be very critical. New grants and funding programs are constantly coming out. Having feasibility studies makes you shovel ready, makes you able to have a plan in place, understand what is possible, understanding how can you react and adjust and adapt to the changing environment, whether it's a political, climate, or financial landscape. Positive returns on investment, net present value. Like I mentioned, looking at these long-term planning strategies, life cycle cost analysis, versus looking at short-term, what is possible now. You want to look at what is possible for the facility's operation lifetime compared to business as usual. Revolving funds, an idea where you can take those savings and reinvest them. We find these to be pretty successful in different organizations and municipalities. So it's one of those opportunities that can improve your success. And feasibility study alignment, like I mentioned, being shovel ready, having an idea of where you want to go, and having those objectives and those that foundation set in I wouldn't say stone, but making sure that you are committed to what you're setting out to achieve. And with that said, there's a Q&A session, and pass on to Jillian.
Thanks very much, Cajun. Really appreciate that. And thanks very much to Sean. some great insights in there. We do have a question, and now's the time to ask your questions. Please do put them in the Q&A section. We do have a question, either Cajun or Sean, around grants or incentives for low emissivity ceilings.
Um, I'm not sure of low E ceilings specifically. You know, uh, there are more and more grants and programs coming out that look at not specific equipment, but I would say, yeah, like I guess someone mentioned the custom track application. So like, energy savings. So there's going to be, can you save this much energy and how much from saving this much energy, we can offer this much as a grant. Um, so there will be like, FCM has a lot of programs where it's, based on the emission savings and energy savings. And that's how you'd probably apply for those.
I think too that I think Faisal's mentioning it would be a custom track application through either ISO or Enbridge or some utility, in like specifically utility program, which could target a number of different measures, not just low E ceilings. But yeah, that's a great feedback. Um, yeah, this so Faisal's mentioned that they've done it through rat screen analysis and used a custom track, which is great. Thanks very much for that. Patrick is asking about the about how is structural a barrier
Yeah.
for reflective roof coatings? Thanks for
Yeah,
that
I was
question. That's a great question too.
not a huge barrier. Like I mentioned, it really depends on the type of buildings you're working with. Like whether you have a curved roof, whether you have different types of roof structures. You might have um, an issue with uh, what level of reflective roof coating you're going to be able to apply. Whether it's just some reflective paint or something more durable long term, depending on weight restrictions and things like that. It's not like an end all barrier, but it is just a very light barrier, I would say, if anything.
Okay, fantastic. Any other questions from anybody in the audience? Give everybody a second to ask any other questions. Oh, yeah, we have a question here. Taking into account the typical electricity and natural gas costs for an ice rink, what's a typical range of the spark gap between electricity and natural gas in Ontario? How does that vary nationally? Hmm. Do you want to take that on?
Um, I feel like this is not a question I can probably answer, outright in the middle
No.
of a QA.
Yeah,
It
we'd
would be
have to do
a bit, yeah, a bit of it would require a bit more comprehensive of an answer, and I can't say I have an answer
off the top of
off
your
the
head. Yeah.
grill. Yeah.
Yeah, no, totally fair, but it's a great question, and we'll take it away and maybe provide this afterwards. Um, we have had a couple of questions about this presentation and where it will be. We do upload, and we'll send out an email to everyone who's attended. We do upload the recording of this presentation to our website. And if there are any questions that we weren't able to answer, we will also provide answers as well. So you will get a copy of this to be able to look at later and to refer to later, or if you wanted to save parts of it and use for your municipality. So probably move on to the next. If we could go to the next, if there's no more questions, I'll just take one more. No, no more questions. Just wanted to get your feedback, and I really appreciate you listening through all of this. We are doing some research on high performance air source heat pumps to really look at accelerating take up and implementation of air source heat pumps in municipalities, looking at identifying barriers and working with industry to identify equipment solutions. And there will be feasibility study reports that'll come out of this, and we'll be documenting findings and conclusions in a guide and case studies that we'll be launching through a national webinar. sometime in 2026. So for this research, we did want to ask you a few questions, which are going to be absolutely critical to sort of the base understanding for this research. So we're hoping you'll answer those for you. Carolyn, if you could launch that for us now, that will be excellent, and hopefully we'll get your feedback, and this will really help us going forward. So we'll give everybody a couple minutes to answer this, and then share the results with you. Nothing like silence for this. Okay. Excellent. So if you could, Carolyn, share the results today so far that we've got, and we can move on. People can continue to answer them while I just go over our upcoming events. Oh, here we go. Let's just take a look at what we see. Can everybody, hopefully the attendees can see this as well. So looks like a lot of people are planning, looking at some air source heat pumps, either replacing your gas-fired rooftop units or gas-fired boilers in the next 5 years. So lots of activity there. Heat pumps are popular, so that's excellent for us. Some really good feedback on what would really help you moving forward. Certainly implementation looks big, also lots on the technical, and some useful for the information for the financial and operations as well. So both of those, all of those are there, but definitely on the implementation side and the technical side. So excellent. We'll take that on board. Some clarifications on what more would be useful, and some interest in further participation. So that's great. We'll continue to look at that. It's excellent. And we'll hope get a few more answers from you. I did want to let you know about some of our upcoming events. We've got the Mayor's member networking session coming up October 24th. We have our annual forum open for everyone coming up November 19th, and then members only in-person day on November 26th coming up. So please join us if you are a member for the member sessions, and then everyone's absolutely welcome for the annual forum, where we'll be looking further, going into in-depth looks at implementation and how we can keep moving forward under constraints on our net zero plans. So with that, I really want to thank all of you for attending today. Thank you for we got a little bit of extra commentary in the chat who couldn't submit in the survey. Thank you for that. And we'd love for you to stay in touch. Please email us any questions you have, and we will have the recording posted probably within the week. So thank you, everybody.